This is Geometry, Chapter 8, Section 3, in which we will be studying special right triangles. We know how to deal with general right triangles, a squared plus b squared equals c squared. But there are some special cases which are useful to us if we can recognize them. The first one is the 45-45-90 triangle. You can see we've got two 45-degree angles. That means we have two congruent sides. We're talking about an isosceles right triangle here. The length of the hypotenuse is the square root of 2 times the length of either of the two legs, because they're the same. It wouldn't matter which one you picked. You could get this number from doing Pythagorean theorem if you wanted to, and that would be okay. This will save you some work if you recognize what you have. So given that we have congruent angles here, that tells me we're in the 45-45 case, how could we find the hypotenuse? The hypotenuse is the leg times the square root of 2. If you turn that into a decimal, you would have 4.243. You could leave it in the square root form and it would be okay. Okay. Look at the next one. We're looking for the hypotenuse, and they gave me a leg of 9 times the square root of 2. Well, the theorem says whatever the leg is, take it times the square root of 2. Well, the square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is 2. So we get 9 times 2 tells me that the hypotenuse is 18. Okay. Suppose we have to go the other way. They gave me the hypotenuse, and I have to go backward to find the leg. Well, the hypotenuse is the leg times the square root of 2. I would need to divide by the square root of 2, and when I punch that on my calculator, I find out that the leg is 7.071. Okay. Now let's consider another special right triangle, the 30-60-90 triangle. Okay. When you're dealing with a 30-60-90 triangle, the hypotenuse is twice the length of the short leg. The short leg will be the one across from the 30-degree angle. And the long one is the square root of 3 times the short one. So everything hinges on the short leg. Now, you can think about this in two different ways. You could use this triangle that just has the x square root of 3, and the 2x, and that would work. Or you could use this triangle, S for short leg, L for long leg, and then have these two equations. Either way works. They say the same thing. It's just a matter of how you want to approach it. So let's do a little calculating in a 30-60 scenario. We have 30-60 triangle. Which thing did they give me? They gave me the long leg. Well, to get to from the long leg back to the short leg, long leg equals short times the square root of 3. Divide by the square root of 3 then to get to x, which is 6.928. You could leave it in this form if you wanted to. It would be okay. Now that we know the short leg, we can find the hypotenuse, because the hypotenuse is 2 times the short leg. Well, that means it's 2 times just under 7, which is a shade under 14. Okay. Let's try our second one here. In this case, they gave me the hypotenuse. Remember, everything hinges off the length of the short leg, so let's find the short leg. The hypotenuse is twice the short leg. So 10 equals 2y. Dividing gives me what the short leg is. Now that I know the short leg, I can find the long leg. Sorry. Looking for the long leg here. X is the short one times the square root of 3. Punch that into my calculator and I get a nice decimal. Or I could leave it 5 square root of 3. Either way. Okay. One more. In this case, what we have is the short leg. Well, good. That makes everything a lot easier. The long leg is the short one times the square root of 3. Punch that into my calculator. The hypotenuse is 2 times the short one, which gives us 42. So 2 basic triangles, 2 basic theorems to work from. All you have to do is follow the equations that I gave you, and everything will take care of itself. Just pay attention to which triangle you're using. If you had questions along the way, hopefully you wrote those down. Bring them in and ask, and we will see you in class.